Alright guys, so here's your help for 7.4 number 8. What I did was I already translated it. You have to prove that a segment that's a perpendicular bisector passes through NT. What you'll notice is that I used RS as a perpendicular bisector as part of my given, because the part that I'm trying to prove is that the perpendicular bisector passes through that. So I need the perpendicular bisector information in my given to be able to say that it passes through the point, and RS will become RP. I'm going to show you what that means. And obviously we had a regular pentagon, so we're going to start with that. So I'm going to name it penta, and we're just going to come up with some kind of plan. So first what I'm going to do is RS is a perpendicular bisector, which, let me put R on here, and point S. I'm just going to set it right here. And what I'm going to do is I'm going to draw this line, because it is our given, okay? But I'm going to slide it just a little bit for now, because I just need to prove that RS is the same as RP. So it's the perpendicular bisector, and we'll use that information in a minute. And then our regular pentagon. So first I'm going to prove that this, I'm going to write my givens, and I'm also going to add some lines in. Because if I really want to be able to prove that if this is a perpendicular bisector, if I have an isosceles triangle, and this is perpendicular, and it bisects, it's the perpendicular bisector to the vertex, to the base of your isosceles triangle. So that's what I'm going to use. I'm going to use Pn is and Pt, and we'll use the problem that we did in number 5. We'll prove that this is an isosceles triangle. And then what we'll find out is that if this is the perpendicular bisector of the if it's the perpendicular bisector of an isosceles triangle, then I can slide RS to be RP, because P will be equidistant from N and T if this is the perpendicular bisector. So we're going to start with our given. You got penta is a regular pentagon given. And then I'm going to draw these lines in. So I'm going to write draw Pn, PR, and PT. Okay, because 2 points determine a line. You know how that goes. All right, this is going to allow me to choose the information from my given that I want to mark. So I'm trying to prove these are isosceles, which we did in number 5. So remember, we marked these as congruent sides and those angles as congruent, and we proved that this was isosceles. So what we're going to state first are that the sides are congruent. So we're going to say that PE is congruent to PA, and EN is congruent to AT, because you have the reason, if it's a regular pentagon, the sides are congruent. And we're going to say angle A is congruent to angle E. And same thing, you know, angles inside a pentagon are congruent. This allows us to prove side angle side. You will have to write down here what triangles you found were congruent. Okay? And then you need to prove the CPCTC and get these sides of these triangle right here, PNT, as a congruent isosceles triangle. But you really don't need to say that, because as soon as you prove that P is equidistant from N and T, and we use the given that this is our perpendicular bisector, like that, we can prove that P is equidistant from N and T, that the perpendicular bisector has to be part of that line. Okay, So we're going to go with CPCTC, and then we're going to say after that that NR is congruent. Oh no, we can't say that because we have to say our perpendicular bisector. So we're going to go get RS is congruent, not RS. Yeah, RS is the perpendicular bisector of NT. We do need to state that, so there's a given. And since we said up here that PN and PT were congruent, and we've got perpendicular bisector, we can say then that NR is congruent to TR because bisectors divide segs into two congruent segs. That's what a bisector does. And what you get to say now is that PR, which is the line that's this line, PR becomes PS. Because our RS, I'm sorry, they become the same line at that point. Move it over. We've proven it. So PR is now the perpendicular bisector of NT. And if it's the perpendicular bisector of NT, then you can say that RS passes through, because we just moved it, because we proved it, P. Because a seg only has one perpendicular bisector. It can't have two. So RS becomes RP. And there you go. Hope that helps.